Antonio, Antonio, wherefore art thou, Antonio? You know what, I don't think even he knows. The poor guy is all over the place. If you're not up to speed on this, then feel free to watch my last video, where I proved that an auto level line on this image is around 0.04 degrees above the horizon, something good old Antonio thought was impossible. I'd bet him that I could prove this was the case, and he accepted. He'd agreed to publicly admit he was wrong if I could do it. He seems to think, though, that he didn't accept anything.
When I hadn't had a reply, I left him another on the next day's video. I repeated my point and the challenge. In fact, I waived the £100. I said, look, how about if I can show you this, you publicly admit that you were wrong. Do you accept? And he did.
There's no mention there of waiving £100. It says, I said, cool, paste a link when you're done. And he said, super, maybe a few days, some travelling, blah, 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 blah. Nothing about a wager. And I said, cool, that was it.
But if he'd bothered to read my comment, he'd have seen it, right there, where I said all of those things. I guess reading isn't one of Antonio's strong points.
Oh, oopsies.
Oopsies indeed, Antonio. So to calculate this, I used the restaurant on the CN Tower as a benchmark, as it has a known size and it's a known distance away. And we could use this formula to calculate its angular size. I even explained exactly how this formula is derived from basic high school level trig. Well, he didn't take too kindly to this and proceeded to say this about the use of the angular size formula.
E, so the height over 2r, what's 2r? Twice the distance, that's right. Let's continue. You should have checked your teacher. In mathematics at school, I was a straight A student until they started teaching this, at which point I bailed. I told the teacher, this is not true. I didn't quite bail, I was kind of pushed out of, well, not physically, but you know what I mean. Why? Because the distance between you and the object is fixed. You can't just magically double it. When you're supposed to be doubling the size of the angle, which is what you're supposed to be doing, doubling the tan, yes, you can't just instead double the distance. That's stupid. The dim-dim doesn't realise if he did it without doubling the size of the distance, he would arrive at twice the angular diameter. Well, if the distance is x, let's make the distance x times 2. That's right, let's do that. You complete dim-dim.
Well, Antonio, it's really no wonder you didn't finish maths class, if you can't follow the simple derivation of a formula. Don't worry though, I'll walk you through it again. Baby steps, pal. Keep listening, champ, you'll get there. So we start with the formula for this angle A in this right angle triangle of arctan opposite over adjacent. We want to find the full angle, so we need to multiply this by 2. We're looking for 2A, so we multiply the other side by 2 as well, which makes 2 times arctan opposite over adjacent. Now we could just use this equation and it would work, but it would mean dividing the object's size in half every time we ran the calculation. So to make the opposite side equal to g, which is the actual size of the object, we need to multiply the opposite side by 2. But if we're multiplying opposite by 2, we also need to do the same to the adjacent. Otherwise, our fraction will not stay the same. It'll be unbalanced, Antonio, much like yourself. So we also multiply adjacent by 2. So now we have 2 times opposite divided by 2 times adjacent. This fraction is now the same as this fraction, and it's in balance. Now we can replace the adjacent side with r, because they're the same. Adjacent here is the same as r here, and we end up with the angular size formula. So 2 times the opposite over here, 2 times the height is the same as g there. 2 times the adjacent over here is the same as 2r down here. So that's how we have 2r in the formula, Antonio. Do you see? Do you understand?
That's just not true.
Well, it is, I'm afraid. But if you still don't follow, let's just prove it. Let's substitute some values in and see if both equations come out with the same result. So we start with our right angled triangle. We have an opposite side of 10 and adjacent side of 20. We're looking for angle A, which is arctan opposite over adjacent. So substituting in, we have 10 over 20. So that's arctan of 0.5, which is 26.565. Multiplying that by 2 because we're looking for 2 times that angle A, and that is 53.13. Now let's do the same thing with our angular size formula here. And now we're looking for alpha, which is that entire angle, which is the same as 2a. So we have g over 2r. G is 2 times the opposite side, which is 20. 2r is 2 times the distance, which is 40. And look at that, you end up with 2 times arctan of 0.5. 20 over 40, Antonio, is the same as 10 over 20. So alpha equals 2 times 26.565, which of course is 53.13. So there you go. Maybe you should have listened to your teacher after all.
Oh, oopsies.
Oopsies indeed. Now I'm big enough and ugly enough to admit when I'm wrong. And Antonio did point out a couple of things I could have done better. I could have used the exact distance of 30.84 miles rather than rounding to 30 miles. And I would have got an angular diameter of that restaurant at 0.053 degrees instead of 0.054. I could have measured the pixel width of the restaurant a little better than I did, and if I'd done that I would have got 30 pixels instead of 32. So let's see what difference that makes. So using the correct distance and measuring the pixel width to 30 pixels instead of 32, we get an angular size of 0.044 degrees. Still not far off the 0.04 degrees Antonio was so sure was far too small. So what do you have to say about that, Antonio?
Oh, oopsies.
There we go. But wait, what's that? You've found another problem.
You think you're working that out, you dim-dim. But that's only about 3 miles away. She's only standing 6 foot above the water. Do you understand? You can't take the angular resolution of something at 30 miles away and say, and what would it be at 3 miles? We're pretending like this 30 miles, it's at 3. Do you understand? You complete moron. You just complete delusional moron.
Really? Antonio, angular size is a relative measurement from the viewpoint of the observer. Something that's 1 degree 3 miles away is the same size to the observer as something that's 1 degree 30 miles away. The absolute size of those objects will be very different, but the angular size will be the same. So when we're talking about comparing sizes purely based on angular size, distance is irrelevant. Did you miss that maths class too?
Oh, oopsies.
Oh, but wait, hang on. There's something else.
You don't know, we don't know. Is the Roger Centre compressed or is the tower expanded? Which one it is, one or the other?
Hang on, so you think there could be horizontal refraction, making the restaurant appear wider than it is? Really? If you know anything about atmospheric refraction, Antonio, you'll know that light bends towards a denser medium. That's why objects such as the Roger Centre can appear above the horizon when geometrically they shouldn't. The light from it bends towards the cooler, denser air next to the water. Just like in this test showing light refracting around a curve when the surface is cooled. This video is by Dan Joss. Link is in the description if you want to check it out. So for this to happen to the width of the restaurant, there would have to be a horizontal temperature gradient from one side of the tower to the other. So a vertical strip of warm air with cooler air either side of it. Does this seem likely, Antonio? How would that happen, Antonio? And didn't you say yourself that horizontal and vertical compression is different? Here, let me remind you.
As the refraction at the astronomical horizon is typically about half a degree, that means the usual compression is about 1/6 of the vertical size of an object at the horizon. We are discussing objects at the horizon. There is a compression, it's in bold there. There's a compression. Okay? Okay. So it does matter. Just to let you know, up and down versus side to side, it does matter.
Up and down versus side to side, it does matter. We're talking here about vertical compression, Antonio, not horizontal. Vertical. And as you said yourself, it does matter. How you leap from vertical compression close to the horizon to horizontal expansion across a clear line of sight is astonishing.
Oh, oopsies.
Yep. So I'm getting close to leaving this one here. In a follow-up video, he decided to try and use the actual height of the Rogers Centre as a measure of angular size in the image, in an attempt to salvage this train wreck, as if he has some proof that the entire height of the centre is visible in that highly refracted image. We can see from this comparison of another Genefredo shot that Antonio happens to like, and a closer photo of the same scale, that the part of the dome we see is much less narrow than the full-size building. And if we overlay them, we can see clearly that we're only seeing the top of that dome.
Oh, oopsies.
Antonio then tried to deflect by issuing me some random challenge about drawing the route of the China-Europe block train on Google Earth and trying to replicate its stated length of 8,077 miles. The only maps of the route I could find were like this, high-level, simple maps which show nothing of the twists and turns that are bound to be part of this route as it winds its way through mountain ranges and across varied terrain, adding to its overall length significantly. Basically, this was a pointless challenge, but nice try. But I have a friendly challenge for you, Antonio. No bet, no wager, all I'm looking for is an explanation. This is a video on my channel from a couple of months ago. All I want to know is how, if the Earth is flat, can Mount Erie overlap any part of Mount Rainier in this image? Watch the video, let me know. But back to the matter in hand. Do you now agree that this yellow line is approximately 0.04 degrees above the horizon? Yes or no? I really don't see how you can't. So, as agreed, admit you're wrong, Antonio.
That's just not true.
Sorry pal, but it really is. Thanks for watching, and if you think Antonio should publicly admit his mistakes, go ahead and give this a thumbs up. See you soon.